Alright, so in this video we're just going to be working through this worksheet from 2.7 and let's see how we do. So number one, we just have 9x squared minus y squared is equal to 1, and we want to write dy over dx in terms of x and y. So again, we're treating y as a function of x. So the x here is the independent variable, and so when we differentiate, the 9x squared is just the normal derivative, and so that would just be 9 times 2 times x to the 1, or just 18 times x, and then the minus the 2 comes down front for the y to the 1 power, and now we multiply by the derivative of the inside function. So this is like f of x squared, right? So off to the side here, this would be like if I were to differentiate f of x squared, right? So the derivative of that would be 2 times f of x prime, and so the same thing happens here. Good, and then the derivative of 1 is 0. Okay, and so move the 18x over, divide by 2y, and you get the y prime is going to be 18x over 2y, which is 9x over y. Good. Or you could write that as dy over dx. Let's see, that's 1a, I guess, huh? And so b is going to be, this one's a little bit more complicated here. X to the 4th times x plus y is equal to y cubed, y squared. I'm trying to see that. Y squared times 3x minus y. You know, and I did this a couple of ways, and I think probably the most straightforward way is just to go ahead and distribute the x to the 4th in and the y squared in. So let's just go ahead and call that x to the 5th power plus x to the 4th times y is equal to 3xy squared minus y cubed. Okay. So now when we differentiate, it'll be a lot more straightforward, I think. So the x to the 5th is just 5x to the 4th. And now the derivative of x to the 4th times y is a product rule. So the derivative of x to the 4th, that's the derivative of the first function times the second, plus x to the 4th times the derivative of y, which is just be dy over dx, equals, now we differentiate 3x times y squared. So the derivative of 3x is 3 times y squared plus the derivative of y squared times 3x, or 3x. Now the derivative of y squared is the same as what we did up here, right? So that's going to be 2y dy over dx. Okay, and then we subtract that from the derivative of y cubed, which will be 3 times y squared times dy over dx. Good, this is why I was saying it is kind of a long expression here. Okay, so let's see if we can isolate the dy over dx. I'll bring this term over and this term back, and then I'll factor out the dy over dx. So we'll have a 5x to the 4th plus 4x cubed y, and then bring this term over, so that's going to be minus 3y squared is equal to, and now I'm going to bring the, well, let's go ahead and take care of that's going to be 6xy here, and then I'll have minus 3y squared, and then I'll have minus x to the 4th. Okay, and that's all times dy over dx. Good. We're just about there. Now we just divide both sides by this 6xy minus 3y squared minus x to the 4th. And we're all done. If I take 5x to the 4th plus 4x cubed y minus 3y squared and divided by this mess, right, that's going to be equal to our dy over dx. Very good. So that was kind of a long one. Let's see, we're up to about 5 minutes. Let's see how we do on the next one. That's cosine of x times y. That's equal to 1 plus sine of y. And we want to again find dy over dx in terms of x and y. Alright, so the derivative of the cosine is minus the sine, and then the inside function is x times y, right? And now we multiply the whole thing by the derivative of x times y, and so the derivative of x times y is going to be a product rule. So that's 1 times y plus x times y prime. Good. Equals derivative of 1 is 0, derivative of sine is cosine, and so again we have to use the product rule, or sorry, the chain rule, and so that's going to be the derivative of sine, that's cosine with the inside function there, times the derivative of the inside function. Good. Now just like before, let's group our dy over dx terms together, and then we'll have our sine of, let's see, that'll be minus y sine of xy on this side, and then on the other side we'll factor out the dy over dx. So we've got this cosine of y, maybe I'll put that over there, and then we have minus x sine of xy. Right, so bringing it over to this side becomes a plus x sine of xy. Good. And now just divide by that quantity, and then we've got our derivative. So minus y sine of xy divided by cosine of y plus x sine of xy equals dy over dx. Good. I'm going to pause for a minute and bring up the next problem. Okay, I think we're running again. Yes. So 1D is we're given the arctan of x squared times y is equal to x plus xy squared, and again, just like the last problem, we want to find dy over dx in terms of x and y. So the arctan is one of the problems that we had in the previous section. So you'll remember that if we have arctan of x, the derivative is 1 over 1 plus x squared. Good. So the derivative of the arctan is 1 over 1 plus something squared. And that something is whatever's the input here. And so in this case we have our x squared times y here. And then you have to multiply everything by the derivative of that inside function. So I'm just going to write it as x squared y prime for now. And then the derivative of x is 1. And then the derivative of xy squared, I'll just write it as xy squared prime. Okay. Now to continue, leave it a little bit of room here. Let's see, that's going to be x to the 4th y squared. And now I'm going to differentiate x squared times y. And so that's 2x times y plus x squared times dy over dx. Right, so that's a product rule is equal to 1 plus, oops, that's a 0. No, I've already differentiated that. That's confusing, isn't it? So I'm just bringing down the 1 because that's already been differentiated, and now I need to differentiate that term. So that's again a product rule, so that's 1 times y squared plus x times the derivative of y squared, which we've done a couple of times now. It's 2y times dy over dx. Good. And now you can distribute so that we can bring all the stuff with dy over dx on one side, all the other stuff to the other side. So I will have 2xy divided by 1 plus x to the 4th y squared on this side, and then I'm going to bring the 1 over, and then I'm going to bring the minus y squared over, right? And then on this side I'm going to bring this expression, so that's going to be x squared over this stuff. Let's see, I'm going to have 2xy here, and then minus 2xy divided by 1 plus x to the fourth y squared, dy over dx. Good. And now I just divide by this quantity, and so we would get 2xy over 1 plus x to the fourth y squared minus 1 minus y squared, all divided by 2xy minus 2xy over 1 plus x to the fourth y squared. Now, here we've been able to solve for dy over dx. Generally speaking, we wouldn't want to leave a fraction within a fraction, but in this case, I think it's okay to leave it in that form. So we'll just leave it in that form. Very good. Let's see, we've got 2 more problems to go, so let's see how we do in part E now. So in part E, we have the tangent of x minus y is equal to y over 1 plus x squared. Good. So now we just differentiate both sides with respect to x. So derivative of tangent is secant squared. Leave the inside function in there, and multiply by the derivative of the inside. Then on this side, think of this is a quotient rule, right? And so we're going to have the derivative of the top. Oops, this is going to be equal sign here, right? Derivative of the top times the bottom minus the top times the derivative of the bottom, so that's just going to be 2x, all divided by the bottom function squared. Good. And so down here, we'll go ahead and finish this one up as well. That'll be 1 minus y prime. Good. And then here we have our y prime. In fact, maybe I'll go ahead and break this fraction up. So I have y prime times 1 plus x squared divided by 1 plus x squared squared, right? And then minus 2xy divided by 1 plus x squared squared. Good. So I'm going to bring this over to the other side. I'm going to bring this through, and then the minus y prime term here I'm going to move over to this side. So what am I going to be left with? I'll have the 2xy over 1 plus x squared squared from here, and now I still have my secant squared over on this side times 1, right? And then the y prime one I'm going to move over to that side. So let's see, that'll be, oh, by the way, this cancels with one of those, right? So I'm going to have 1 over 1 plus x squared, and then bringing this secant squared over, I'm going to have minus secant squared times x minus y dy over dx. Good. That's a big expression, but we're just solving for dy over dx. It's already pretty much there. So we just divide the whole thing by this 1 over 1 plus x squared minus secant squared x minus y. Good. That's gone now. And now this is dy over dx. I know that was sloppy. But yeah, we're kind of running a little short on time, so didn't want to get too carried away there. So how about number 2? We have y sine of 2x is equal to x cosine of 2y, and we're at the point pi over 2 pi over 4, and we want to find the equation of the tangent line. Good, so we know the point that the line goes through, so next we just need to find the value of the derivative at that point. Good. So this is going to be a product rule on this side, so we'll have y prime times the sine of 2x plus y times the derivative of the sine of 2x, which will be cosine of 2x times 2. Good, and then on this side we have another product rule. That's going to be 1 times cosine of 2y plus x times the derivative of the cosine of 2y, which will be minus the sine of 2y times 2y prime. Okay, and now let's just go ahead and put in our point. X is pi over 2 and y is pi over 4. So y prime is the unknown, so sine of 2 times sine of pi over 2 is going to be sine of pi. Cosine of 2x is going to be cosine of 2 pi. So this is going to be y is pi over 4. Pi over 4 times cosine of 2 times pi over 2 is cosine of pi times 2 is equal to cosine 2 times pi over 4 is going to be pi over 2 plus x is pi over 2 minus the sine of 2 times pi over 4. 2 times pi over 4 will be pi over 2 times 2y prime. Good. Now, sine of pi, what is that? If you're not sure, just draw a quick sketch. There's my very rough sketch of sine 2 pi and pi. Sine of pi is 0. That's 0. Cosine of pi. So remember, cosine comes down and then up. Cosine of pi is right in the middle, -1. And so this is going to be pi over 2 negative pi over 2, right, is equal to cosine of pi over 2. Cosine of pi over 2 is right here, so that's going to be a 1 plus pi over 2. Now what's the sine of pi over 2? This was pi. Sine of pi over 2 is actually, oh, that's my cosine. Where's my sine? This is, wait a minute, cosine of pi over 2 was 0. Good. Let's see, where did that one come from? Okay, maybe we should reevaluate this side. Cosine of pi over 2, there's my cosine function up here, not here. This is my sine, and this is my cosine. So cosine of pi over 2 ends up being 0. And then we have our pi over 2, and then sine of pi over 2 is 1, so that's going to be -1 times 2y prime. Good. So can we solve this for our y prime now? Get close to the bottom of the page there. So minus pi over 2 is equal to, let's see, minus the 2's cancel here, minus pi times y prime, right? So divide by negative pi, and we get that y prime is equal to 1/2. Good. So now I have my slope and I have my point, and so the equation of the tangent line will be easy to write. It will be y minus pi over 4 is equal to 1/2 times x minus pi over 2. Good. So that was kind of a long video, 20 minutes, but we managed to write down all the solutions to the exercises. Good.